Okay. Yo. Day 4, coding target job. So today's question, we're going to be tackling a medium. So this is a bit of a step up. But it's a group anagram. So the question reads, given an array of strings, group all anagrams together in a into sublist. You may return the output in any order. An anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. So the example shows that it's like axe, pot, stops, cat, stop, hat, and obviously these are anagrams, so they get grouped together here, and the rest for the so on and so forth. So we want to go O of m n squared time complexity. Okay. So let's crack open the IDE. Let's have a go. So first of all, we know that an anagram is a string of the exact same characters, but the order is different. And we want to find the groups of anagrams. So like I said, act and cat, one group. Stop and pot, second group. So we kind of just go from there onwards. So the first thing we want to do is we want to test for edge cases, because we want to maintain that the time complexity is always going to be consistent. So the way we do that is that, very simply, so if we got a length of 0, then we are going to return an empty list of string. So basically just an empty anagram. So empty string, like group. Next, we need to initialize a dictionary. So we can actually compare the values. So we need to initialize the dictionary so we can compare the values. So the way we just do this in C# is that we do dictionary, and so we want a key value. So the value is going to be the groups of anagrams, and the key has to be the strings converted into characters, because like we said, anagram is same characters, different order, so they will have the same key, and you can group it in different group values. So therefore we're going to do something like this. I think we can do this, can't we? Yeah, that's nice and sweet. Then we need to loop through what we've got given. So that's what we're looping through what we've got given. And then since we're dealing with characters, we need to initialize a count up to 26 characters. So that would, yeah, because that's the range we're working with. So that would kind of look like this. Then we are going to create the key, and the key has to be the characters in the string. Since they're always going to be the same, we can kind of make a hash for each individual group, and then because this is the value is going to increase per key. So say I had apple, and I don't know what anagram of apple is off the top of my head, but if I had no anagram of that, it would have the same key and the value would increase. So that would be two things, and one of them would be apple and the other thing would be whatever you can think of that's an anagram of it. Apple? I don't know. So create a hash. How would we do that? So first we go work with a count. So we're gonna do something like this in the words, and then we're gonna do count C for the character minus the character. Yep. And the character A plus plus. So basically it's just gonna give us like, where do we put it? So we're kind of like adding on to the key. Then we need to make the key pair. So the way I do this in C# is use a string builder, because if you modify a string, that affects the time complexity, but with a string builder it wouldn't. And then we can just convert what we created in the string builder to a string, instead of just modifying it every single time. So the way we would do this, string builder, and then we would say, so we need to create the hash. So that's gonna go from I and I 0. Then we're gonna go up to 26 because that's the length the characters possible. And we're gonna append a little hashtag C#. Hashtag. You can do whatever you want to be fair, it doesn't really matter, but just like visually it'll be better. And then you can just append the count as well. And then, like I said, we create the key by converting it to a string. So actually, let me show you guys what I mean by this, because it will make a lot more sense. Okay. Second. So that's going to be the key. generate a couple times. So as you can see, I think this one is identical. So these two must have the same characters and therefore must be anagrams because they're identical. It's an easy way to map and group them together. Like, that's really the purpose of why we do that. Okay. So then, once we've created that, we need to check if the key is already in our dictionary, and if it is, or if it is, then we increment the value. So we're saying we've got 2 pairs of that, and if it's not, we add it to the dictionary, saying that's going to be a separate group that we're going to populate. So what this would look like is, yep, like you can hear me. Group anagrams keys new list string, yeah, and then we're gonna say that the key is going to add it in, and then we're going to group the menus. So this is gonna print out the values in here. So if we have a go, yeah, do you know what? Let me show you guys what I mean. So you can go to watches. So it doesn't contain the string. So as you can see, there was 2 in that group and 1 in that group. So see, pots and tops anagrams. So far we've got act. Let's go one more count with this little Kit Kat in here. And 1 second. So you see act. I've got a little Kit Kat. Anagram, so weird. And this lets us group it, so it's working as expected. And if we run the tests, if we submit it, okay guys, see you in day 5.